So our next section, defining rational numbers. So first part, converting decimals to fractions. I know you've done some of this before, so we're not going to spend a ton of time on it. There are two types of decimals. There's what we call terminating decimals. They're decimals that end, like 0.34. It ends. And then the other type of decimals beneath there is repeating decimals that don't end, which is why they're called repeating, like 0.3333 repeating, and we can put that line over there to represent, goes on forever and ever. So, how do you take a terminating decimal and make it a fraction? You put over
100. What? Make it a fraction? I don't know.
Okay.
Move the decimal.
It says at 3/4.
You move the decimal over 2 places and do 21 over 100.
You move it 1 to the right.
What do you think?
You put it over itself.
You put it over 100. Put it over.
You're going to put it over 1,
Yes.
and then we got to figure out the number of zeros, and I'm going to put, so not 100 every time, it's ... It might be over 10, it might be over 0. Where the number of zeros equals the number of
Ones. Numbers. Decimals.
decimals. Okay, so, example, 0.21.
It would be
We take
over 100.
21 over 1, and then how many decimals do you have? You have 2, so you have 2 zeros. 21 over 100. The next one, you're going to put 438 over, and how many decimals do you have?
1,000.
3 decimals, so 3 zeros. So terminating ones, we can just put over 1 plus a certain number of zeros, depending on how many digits you have. Okay?
Yes, sir.
Repeating ones. You're going to put it over 9 ... Or maybe I should put, maybe not the ... You'll put it over 9s with an S. Okay, you're gonna have a bunch, you're gonna have either 1 9 or lots of 9s underneath. Where the number of 9s equals the number of
Decimals.
repeating numbers. So what does that mean?
I don't know.
So this first one, we take the 3, you put it on top.
It'll just be 3 over 9.
And how many numbers are repeating in that one?
1.
Just one number is repeating, so we have 1 9. The next one we have 2 1 8. How many numbers are repeating?
3.
3. 9 9 9. So that's how you tell. That's if it's repeating versus not repeating. Okay. So that's converting decimals to fractions. That's a little bit of review. You did that last year. Rational numbers are numbers that can be written as a fraction. It includes decimals that terminate or repeat. Remember, this terminate is like stop. So it can be a fraction. So that's a rational number. Because it's a fraction. I made it into a fraction. Another one. Number 5. Can I make that a fraction?
No. 5 over
5 over 1. So 5 is a rational number.
You can do that with any number.
Wait, what's
0.37.
What number was it first?
Yeah,
2/3. What?
What's the number for the
What's
first
the
number?
number for
For 2/3? It's just a fraction, so it's a rational number. So if it can be a fraction, it's a rational number. So 2/3 is a fraction, so that makes it a rational number. 5, I can make into a fraction, so it's a rational number.
the odd number?
So 0.37 is 37 over 100. This is what we'd call a terminating decimal, right?
So everything? Yeah, it's A.
0.3 repeating equals 3 over 9, which equals 1 over 3. This is your repeating one. Okay. Another example, 0.8419 would be 8419 over 1,000. 10,000, sorry, I missed a 0. Because there's 4 numbers there. 0.4280 would be 4280, yes, repeating, thank you. Over, how many 9s for this one?
No, first one's supposed to be 4. What is 8 9? 4 9s. Is it terminate or repeat?
This, the 8419 terminates, because I don't have the bar over top of it.
Oh.
So it ends. So rational numbers. Kind of a little understanding of what a rational number is. It's like all numbers but a few of them. Have you heard of this number called pi?
Yeah.
It goes on forever, it doesn't repeat, and it doesn't end. So that one is not a rational number.
Wait. It doesn't repeat anything.
Because pi never, well, some numbers might repeat, but there's no pattern to the repeating. Right, like 4280, when it repeats, it's 0.4280, 4280, 4280, 4280, 4280. Pi is 3.14159, blah, 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 goes on forever.
Down all of it. Does some dude just
Okay.
type it just like?
No, it's all based on circles and all that other stuff. Somebody way smarter than me figured it out. So, rational numbers. So you guys are making comments like, well, that's every number. It's not every number. Okay, there are some numbers that aren't rational. Most numbers that you're going to deal with, especially this chapter, are going to be rational numbers. Okay, so comparing them. When you have fractions, when you want to compare them, you want to change to common denominators. When we have common denominators, it's easy to compare them. Then you just compare the top numbers.
I do that.
So it might say something like this, write these in increasing order. Okay, so we want to make a common denominator. What's a number that's common between 3, 4, and 5?
4.
Like a common multiple.
4? Wait, what? 8.
4 fits into 8, but 3 and 5 don't.
15.
3 and 5 fit in 15, but 4 doesn't.
20.
20. Does 3 fit into 20? No. Does 4 fit into 20?
Can I get my calculator?
How do we figure it out? Remember these factor tree things you just did on your quiz?
Yeah.
3 is prime, 5 is prime, so we need those. 4 is a combination of 2 and 2, so we use 2 squared times 3 times 5.
60.
So 60. So how do you go from 3 to 60?
Times 20.
Times 20. So do the top times 20. So we'd get 40 over 60.
The LCD thing.
How do you go from 4 to 60?
15.
Times 15. So 3 times 15.
45.
5 to 60.
12. 10.
12 is right.
36.
36. So write them in increasing order. What's the smallest one?
First one. No, the last one.
The last one. So 3/5
2/3.
is smaller than 2/3, which is smaller than 3/4. So there's my increasing order.
I feel like I could have done
All right.
Look in my head.
So that's one way. Make them all fractions, find common denominators, put them in order. Other way. Make them decimals. How do you change a fraction to a decimal?
No, we just did.
Right.
Nope, we went decimals to fractions. How do you do a fraction to a decimal?
You just go 2 places.
I would look at the note on the board in the upper right corner of the whiteboard. It might be partially covered by the screen. Yeah, what does it say? You divide it. So to change a fraction to a decimal, divide the numbers. And it's top divided by bottom. Because every fraction is a division problem. So sometimes you'll get a mix of numbers. You've got decimals and fractions here. So we make them all decimals. It's easy to figure out where they go. So you have negative 1/3 is a fraction. Let's make that a decimal.
Negative.
So what's negative 1 divided by 3?
Negative 0.3.
Negative 0.3 repeating. What's 1 divided by 4?
4.
Mm-mm.
1. 0.
Use a calculator, people.
Isn't 1 divided by 4 0?
0.25. 1/4. 25 cents. 0.25. So now you have 0.3. You have. Let me write these underneath. In different color. You have 0.3. You have negative 0.3 repeating. You have 0. You have a negative 0.3. And you have 0.25. What is my smallest number?
0. No, negative 0.3 repeated.
Negative 0.3 repeating. What's my next smallest? So we've used that guy.
How is that different?
So repeatings are smaller than just 1.
So 0.3 repeating is going to have a bunch of zeros, or a bunch of 3s here. It's going to go on forever and ever.
Negative 0.0.
And as you go more negative, the numbers look like they're getting bigger, but they
But
have.
then that one would only have zeros at the end.
Okay.
Because you're repeating.
So what's next? What's my next number?
Negative 0.3.
Negative 0.3. So that one ends, right? Because you can put zeros here.
Yeah, but then wouldn't that one be bigger?
Nope.
And then 0.
Then 0.
Then 0.25.
Then 0.25. And then 0.3. Notice as you get further away from 0, if you took the negatives away, as you get further away, the numbers appear to get bigger, right? So this is 0.3 away from 0. This is 0.3333333 repeating. The next one, 0.8. Negative 0.8 would be further this way. Negative 0.9 would be further this way, right? So decimals, you can make them all decimals. Now, if it asks you to write those in order, we should actually change our originals back to the form they were originally in. So we really should write our final answer as negative 1/3, negative 0.3, 0, 1/4, and 0.3. If you wrote it either way, I would give you credit for it. The book will probably write it the second way, though. When you're checking your answers, it'll probably take it back to the original way they were written.
You're saying on a quiz or on a test if we did the top ways?
Mm-hmm. But I'm just telling you, when you do your book questions, they will most likely change them back to the original type. Okay? So converting decimals to fractions. Okay, that was the first thing we did. Terminating and repeating are different ways. Converting fractions to decimals, that's just division. And then, does it terminate or repeat? You guys know how to tell that when you get an answer on your calculator, right?
Somewhat.
A lot of you try to tell me it doesn't repeat when you get this 0.6666667. Your calculator has rounded this last digit.
So it
Okay,
doesn't
so it is repeating.
It has like 1 more than 3.
Yeah, if and then if it's, there will be 0.3333333, it'll stop at a 3 here, the last digit, because the next digit would be a 3, so it's not gonna round it up. Okay? So just know if repeating ones sometimes route your calculator around the last digit. Okay? And then writing numbers in increasing order, that's what we just did there. Either convert them all to fractions or convert them all to decimals. Either way works. I don't care which way you go.